Hi, this is Mr. Manley. In this video, I'm going to look at graphing a quadratic equation that is in the form, the general form would be y equals ax squared plus b. Now we can have other quadratic forms and other types of quadratic equations, but we're just going to look at this one where we've got the two terms, an x squared term and what would be called the constant term. So the constant term being the term without a variable, right? So the 3 is the constant term. All right, so graphing this, and there's a requirement here where we're going to want to have 5 points graphed, including the vertex. So of course, presume that you know what the vertex is. The vertex for a parabola, well, let's begin with, we know that this is going to be a parabola. So that kind of U-type shape, and then the vertex, of course, is the minimum point, the lowest point, or if the vertex, or if the parabola is opening downward, the vertex is going to be the maximum point. So we have the vertex for these two different parabolas, either the minimum point or the maximum point. So when we graph this, we're going to want to graph the vertex at the minimum or the maximum, and then we're going to want 2 points to the left and 2 points to the right. So let's take a look at how we're going to approach this. One thing, whenever we are graphing anything, it's always a good idea to have a table of values. Now, it may not be, we might not use the table of values, but it's always a good idea to have that in mind as a default element of the exercise. Okay, so in this case, one thing I'm going to operate off of is that I'm going to operate off of an understanding that you know what y equals x squared looks like. If I just had y equals x squared, I think that you know that this is the first quadratic, the first parabola that you ever encountered, and you know that graphs like this. And that's the first one that we ever had. So if you take a look at that graph, take a look at this one, and then take a look at this one over here, the one that we want to graph, y equals x squared plus 3, is just a little bit different, isn't it? It's just got this plus 3. And I presume possibly that you know what that plus 3 means and what it does. That it's going to take this graph that we have of y equals x squared, and it's just going to bump it up 3 units. So let's go ahead and see how we would execute that. Now that we have the understanding, we're going to take and go up 1, 2, 3 units, and that's where our vertex is going to be. So our vertex was at the origin, but now the vertex is up 3 units. And then from there, now if you go back and look at that x squared that I had, I did have 4 specific points, and those points are, it's over 1 and up 1, and that's one of the points. And then it's over 2 and up 4, and that's another point. And then I did the symmetry of that. So those are my vertex, and then the points to the right and the points to the left. And that's the graph of y equals x squared plus 3. We'll talk about those 2 points to the right and left a little bit more with another example here. We'll go here, and now we've got negative x squared minus 2. So we have hopefully a basic understanding that this is, because of this negative here, the basic x squared that we learned, the first graph that we learned, this x squared graph like that. Now the negative means that it's going to be down, be opening downward. So let's let's go ahead and approach this one a little bit differently and say that we know that it's going to be opening down. So we know the downward part. And then we also know that this -2 here, that's going to bump it down 2 units. -2 is going to bump it down 2 units. And that down 2 units is going to make it look something like this, right? But let's get a little bit more specific here. And let's go into the table. Again, we may or may not need to use this, but I just wanted to show the use of it. That I'm going to plug in x is 0. And when I plug in x is 0, I'm going to go ahead and show all of this. It's way more detailed than is necessary, and I'm sure this is very easy for almost everybody. But if I plug in a 0 for x, and then I look at what the output is, and I get -2. That's my y. And then I'm going to plug in a 1 for x, and that's going to give me -1 minus 2 is -3. And then I'm going to plug in a 2 for x, and that's going to give me -2 squared minus 2, which is -4 minus 2 is -6. So that's 1, -3, 2, -6. Now let me give myself my x and y scale here of 1 unit for each lattice point. And then I'm going to graph these points that I have in the table at 0, -2, at 1, -3, and at 2, -6. 1, 2, 3, 4, 5, 6 there. And then from there, I'm going to go with the understanding of a parabola. If I look at a parabola, it's got this symmetry, right? If I go down the middle of it, everything on the right side is going to be reflected on the left side. It has a symmetry, a horizontal symmetry, if you will. So I don't need to do any more of this business here, where I'm finding any points and plugging in values. I just need to reflect these points. I might show it in the table or not, but I will do it here that, all right, so table-wise, I can go 1, -3, so I have -1, -3. And then I have 2, -6, so that means I have -2, -6. Easier to see this if I just look at the graph and I go, okay, if I have this point here to the right, then I have this point here to the left. If I have this point here to the right, then I have this point here to the left. And there is our parabola with 5 points, 2 to the right, 2 to the left, and the vertex. So this is just a very basic form of graphing a parabola that's building off of our understanding of y = x squared. If I just take it one more step here and say I'm going to go y = 3x squared, let's do a minus here, 3x squared minus 2. All right, so now I still have, it's a variation on this parabola. So it's still a variation on this basic parabola. But now, for one thing, it is moved up 2 units. I mean, it's moved down 2 units, sorry. -2 is going to move it down 2 units. So it's going to move it down here, like that. And then this 3 is going to do something. And I know by looking at the 3, and you may know too, or you may grow to know, that it's gonna stretch it out vertically. But even if we don't know that, and we don't have that in our understanding at this point, what do? We just go back to the table, right? And a combination of using the table and knowing some things about the parabola, like knowing where the vertex is already. So already knowing that the vertex is here, and then I'm just going to go 1 unit, I got the x and y mixed up here, didn't I? So let's see my table there, put the x on the left, which is standard convention, and put the y on the right. So I'm going to go x is 1, and again, I'll show my work here. Y at 1, when x is 1, is 3 times 1 squared minus 2, which is 1. So my output is 1, and then I put in the 2, and that's y at 2 is 3 times 4 is 12, minus 2 is 10. All right, so let's see if I might not even have enough room on my graph here, or maybe I change the scale. 1, 2, 3, 4, 5, 6, 7, 8. So look at that. This is a little good lesson too. You see, I only have 8 units here, but my point that I have found wants me to be able to go to y equals 10. So I'm just going to change the scale here. Let's see if we can jump back in here and get rid of that vertex, because I'm going to replot it with the new scale. And this is really important. Students don't do a great job often, in my experience, with adjusting the scale. So I'm going to adjust this scale and say that each lattice on the vertical axis is actually 2. And this is something that I would like you to see also, that I can keep the x-axis, we've got the x-axis and the y-axis here, I can keep the x-axis at 1. I don't have to have the same scale on the x and y-axis. So students grow uncomfortable or lose sight of that as well. Okay, so with my new scale here, now let's go in and plot the points that I know. So for 1, I know the vertex is at, I already knew that was at 0, -2, because this minus 2 moved the x squared down 2 units. So I've got that graph. And then I've got 0.11. So that's going to be here, right? So I'm in the x coordinate of 1. And then since each lattice on the vertical axis is 2, I'm going halfway between there. So my 1, that's 0.11. And then 0.210 is going to be 1, 2, 3, 4, 5. There's 210 there. All right. And then what I would do from here is I would do the reflection. I'd use the symmetry. So I have this point to the left, there, and then I've got this point to the left, there, and then just give myself a smooth parabola going through those points. And that's it for the basic form of graphing y equals ax squared plus b. Now we could expand this, and then it becomes a different problem, and we'll need different tools if I want to graph a parabola that's of the form, say, of y equals ax squared plus bx plus c. And I'm going to have to use some different tools, like how do I find the vertex in this case, perhaps how do I find the x-intercepts, and recognizing where the y-intercept is, etc. But that'll be a lesson for another time.